Alright, here we have Fall 2019 Exam 1. So starting with question 1, we're looking for volume. So we have these doubles as well as our defined constant. So starting with this equation right here for volume, we have, this is all division multiplication, so we read it left to right because it's the same precedence level. 1 divided by 4, well that's going to simplify to 0. Because remember that an integer, 1 divided by an integer, 4, is going to be an integer result. So we don't care about the decimal, that gets lost. So now we have 0 times pentagon times its power. Well, 0 times anything is always going to be 0. Therefore, we don't even have to finish that line of calculation. We know our answer is 0. Question 2 now, we're looking at area. So we have, once again, 5 times length squared. Well, length is 2.0. And I always like to rewrite it with the decimal just as a reminder that it's a double and not an integer. So 5 times 2.0 squared is 5 times 4.0 or 20.0. Plus 1 divided by 2, once again is 0 because it's an integer divided by an integer. So therefore, we don't care about the rest of that section of the calculation. So we know our answer is going to be 20. So once again, these two questions are important that you're looking at what are your operands, what are their types? Are they floating or integer? Question 3. Which of the following statements regarding the programming and documentation standards of the course is true? A. We comment variables to the right of each declaration made inside the local declaration section of a function. This one is going to be true. So that's just saying, if we have int radius in our local declaration section, we'll say, radius, maybe it's redundant, but of circle 1, or say, user input, whatever, some description. B. All code found inside of the local declaration section of a function should be indented by a tab. This one is false. All code inside of the function of the body should be indented, but the local declaration section is not indented any further. So that one is not true. C. It is permissible to declare multiple variables of similar purpose on the same line inside the local declaration section of a function. So this would be something like we have int x, comma y, comma z. You may see this used in other places online, but for this course we do not use it. This is so that we can comment each variable and just keep everything organized as we still learn. So the answer is A. Question 4. Which of the following statements regarding the design of a program to solve a problem is false? A. Except for the most simple program, one set of test data will not completely validate a program. This one is true. That's why we give you multiple test cases and we add additional hidden test cases. Because we want to make sure that every part of the program works, not just for one set of input, but for any. A lot of times your behavior might change going from small input numbers to large input numbers, as well as 0 or numbers close to 0 may alter some behavior as well. So that's why you give it different types of values as our input to test. B. Software engineering is the use of sound engineering methods and principles to obtain software that is reliable. This one is also true. Right, we want software that doesn't sometimes work, but it always works, that we can trust to give us good answers, so that we don't have to manually go and verify, because that kind of defeats the purpose. C. The development of software should be more concerned about correct results rather than efficient design. This one is false. We want to balance both efficiency and accuracy. Right, obviously, if it's not accurate, it's not a useful program. But if it's not efficient, then we can't use large data sets or easily make modifications to the program. So as we get into more looping and arrays, you'll see that as we have large data sets, things can really slow down if you don't design your program carefully. So C is going to be false. Question 5. Which of the following is the output generated by the first two lines? So we're looking for volume. So volume is hexagon 2.6 times length, which is 3 to the third power. So that's going to be 9.0. So, excuse me, that's going to be 27.0. So volume will be 70.2. And then we're going to use, we have this asterisk right here, which means for our precision modifier, we're going to use a variable to determine what that value should be. So in this case, it's length minus 1 or 2. So you can also rewrite this as 0.2 LF. So that means we have two places after the decimal point. So that's going to be B. Now we have question 6. We're looking at the next two print statements, so we're looking at area. Well, once again, we have 6 times 27.0 plus 2.6 divided by 2 times 9.0. And if you do all that math, you'll end up getting this number, 173.7. So of course you want to verify that if you have the time, but the point of this question is looking at our width modifier. So once again, we have this asterisk right here. We can see we're substituting length times 3 for it. So that's going to be 9. You can also see here that there's one hard-coded space before that percent format specifier. So that means when I'm looking at my answer choices, I want to draw a line right after that hard-coded space, so that we know everything up to that line was actually typed in character by character, and then after that is going to be accounted for by the width modifier. So from this point, I count out 9 spaces. So I see that the 9th space ends at the last dash mark, and there's no minus sign flag, so this is going to be right aligned. Therefore, the number should be on the right side, ending at that last dash. So I know my answer is C, because it ends all the way there. Question 7. Which of the following regarding printf is true? A. The size modifier is used to specify the minimum number of positions to reserve. Well, as we just talked about in the last question, that's going to be the width modifier that's determining the number of spaces. So with our format specifier, we have something like this. Remember that this is width, this is precision, and this is size. So A is false. B, a precision modifier can be used for any type of numeric value. This is also false. So our precision modifier is for the number of decimal places we're displaying, and an integer variable doesn't have any data for a decimal place or anything past the decimal point. So therefore, we cannot use it on integer type variables. C, conversion codes are needed only for the printing of data that is stored in the memory of a variable. Likewise, this is false. So even if we have a literal, let's say we have, printf %d 2, 3, right? We still need those codes to say what type of value we want to display 123 as. Do we want to display it as a char for its corresponding using our ASCII table, or do we want to display it as a number? What type of number do we want to display it as, right? So C is false. Conversion codes are always needed. Therefore, answer is D, none of the above. Question 8. Which of the following statements regarding prefix and postfix expressions is false? A. The result of an expression is undefined when multiple different variables are modified with a prefix operator a single time. Right, so you have plus plus A, plus 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 B. This is totally fine, right? The thing it's talking about is if we were to change A, for example, multiple times in the same line, then it's undefined behavior. But if it's different types of variables, totally okay. So therefore A is false. B, the operand in a postfix or prefix expression must be a variable. This is true. We're not going to do something like 7 plus plus, right? It doesn't even make sense. You're not going to touch that 7 again after the line of code. It's also not something that we can make changes to, right? It's a literal 7. C, the value of the postfix increment expression is determined before the variable is increased. This one is also true. So it's saying that we care about what is the variable now. We're going to use that current value to do whatever calculations that line has. And then when we're done with that line, then we'll make the change before moving on to the next line. So therefore our answer is A. All right, looking at question 9, we have another shape problem. So we're looking at for the volume of this triangular shape. So looking at our data types here, we have a defined constant. We have an int and 2 doubles. As a reminder, I rewrite the 3 as a 3.0 because it's a double, not an integer. This is just a reminder for myself. So looking at this first line, finding volume, we have 0.5 divided by 2 times length. Right, that's going to end up being 0.75. But we need to be really careful, because what are we assigning this to? We're assigning this to volume. Volume is an int. So I'm going to write myself a reminder right here, int volume equals whatever's on the right-hand side. So we have conversion by assignment happening. The right-hand side is a double, the left-hand side is an int, so we need to make them match. The right-hand side needs to match the left-hand side. Therefore, 0.75 gets converted to an integer. We drop the decimal, so now volume is equal to 0. Moving on to the next line, whenever I have this compound assignment, I like to rewrite it as volume equals the current value times square root of 3 times power length to the 4th. Well, we have 0 times some factor. We know the answer is also going to be 0. So therefore, our final value for volume is 0, and our answer is A. Moving on to question 10. Now we have everything inside these parentheses casted to an integer. Well, I'm going to rewrite that formula inside the parentheses as 0.5 times the square root of 3 times 3 to the 4th, which is equivalent to 3 to the 5th, or 243, which looks a little bit scary. But whatever the answer of this is, we're going to cast to an int, or take the floor of, drop the decimal. So we can make a good guess without needing to be precise with the square root. So we know that 15 squared is 225. 16 squared equals 256. 243 is somewhere in between 225 and 256. So let's just choose a number that's in between 15 and 16. Let's do 15.5. Well, now we have 0.5 times 15.5, which is going to be 7.75. We cast this to an int. Because of that explicit conversion, we drop the decimal, and now it ends up being area is equal to 7. You can try any number in between 15 and 16. It has to be less than 16. But you'll end up getting 7. So this is why we can make that guess at the square root. So now area is equal to the current value, 7, plus 3 times 3.0 squared. 3 times 3 squared is 27. 7 plus 27 is going to be 34. So our answer is B. So now we're being asked which of the data type conversions did not appear in the code segment above. Well, if you watched the video on the last 2 questions, you would have seen that we had implicit conversion, right? This is going to be 0.5 divided by 2. That 2 gets promoted to a 2.0 so that the two sides match. They're both floating type. We have explicit conversion right here when we casted our 15.5 times 0.5 to an integer. And we had assignment when we had 0.75 on the right-hand side here, a floating type, and then an integer on the left-hand side. So we needed to make the types match. Therefore, all three types of conversion appeared, and our answer is D, none of the above. Question 12. Which of the following statements regarding modulus is true? A, this equation will only result in 0 or 1 for any non-negative integer. Well, non-negative is the same as 0 and all positive values. So I'm going to make a little input-output table. Right, I'm just going to do 0, 1, 2, 3. Any large number, I'm just going to make the assumption that it acts the same, but these numbers close to 0, or close to the numbers in the equation, 1 and 2, may change the behavior. So, for x plus 1 mod x, in each row we're going to have 1 mod 0. Well, that's going to be division by 0. That's going to cause an error. So therefore, we know that this whole column cannot be 0 or 1 because 0 would already result in that error. Moving on to B. If our input was 0, that would be 2 mod 1. Any number mod 1 is 0. And it's asking us, is every output 1? Therefore, it can't be B. For C, we're looking if every single output is 0. Well, we have 1 minus, then just a reminder, we're going to add some parentheses because of precedence. X plus 2 mod x plus 1. So if our input is 0, this is going to be 1 minus 2 mod 1. We already know that 2 mod 1 is going to be 0, so 1 minus 0 is 1. Therefore, that's not the output we want, and C can't be our answer either. Therefore, our answer is D, none of the above. All right, question 13. We're continuing to look at modulus. So we have three integer variables, and we're looking for x and y. Well, here we have x equals x mod y, or 19 mod 8. Remember that modulus is our remainder, so 19 divided by 8, you get two whole groupings to form 16, and then you have 3 left over. So therefore, x is equal to 3. Y is equal to y mod z. 8 mod 5 is also going to be 3, because you have one full group of 5 and 3 left over. Therefore, our answer is B. X is 3, y is 3. Question 14. Now we're looking for z. So z equals z mod x, 5 mod 3. Well, we have one whole grouping of 3 and 2 left over to form 5. Therefore, our answer is C, 2. Now we're working with some postfix and prefix, increments and decrements. So for question 15, we're looking for the value of y. So y mod equals x plus 1. So I like to rewrite this as y equals the current value of y mod, and then in parentheses, x plus 1. Well, x is currently 3, so it's going to be the same as 18 mod 4. 18 mod 4 is 2, because we have 4 whole groups of 4 to form 16, and then 2 left over to reach 18. So y equals 2. Our answer is A. Now we're looking for result 2, which is plus x plus z minus minus divided by 3. So I'm going to add some parentheses as a reminder of precedence, division first. So z minus minus divided by 3, because z is a postfix decrement, we're going to ask what is the value of z right now. The current value of z is 12. 12 divided by 3 is 4. Plus x, because it's a prefix increment, the plus signs come before. We're going to change x first from 3 to 4, use the new value, add them together, and our answer is 8. So our answer is C. Now that we're done evaluating this line, we're going to decrement z to 11 because it had a postfix decrement. Moving on to question 17. Which of the following is the third line of output generated by the code segment above? So we're looking for z plus x. Z is equal to the current value of z plus z divided by minus minus x. We're going to make the change to x first and use that new value in our equation. 11 divided by 3 is integer division, so the result is going to be 3. We don't care about the decimal. 11 plus 3 is 14. Therefore, our answer is 14 plus x is 3. Our answer is B, 17. Question 18. Which of the following statements regarding user-defined functions is false? A variable declared in the local declaration section of a function can have the same identifier as one of the parameters of the same function. So this would be something like saying, we have a function, do this, and let's say we're passing in a radius. Inside this function, we also have another variable called radius. These have the same identifiers, so therefore you're going to throw an error, because if you tried to reference radius later in your function, how would you know if you wanted to refer to the parameter or the local variable you just declared? There's no way to differentiate based on the name. So A is false. B, a local variable cannot be referenced through its identifier outside of the function in which it is defined. This one is going to be true. It is the concept of scope. So when we define a local variable, we say that anywhere in this body between the curly braces of the function, from where it's declared to the end, you can refer to that variable, but nowhere else. This protects us from making unwanted changes in other functions that you would get with something else like global variables, something we don't allow in the course. So therefore B is true. C, parameters are defined as local variables in the first line of the function definition and should not be redefined in the local declaration section of the function. This one is true, and it's kind of similar to A, right? So we already have int radius up here, and the parameter list, we don't need to have another declaration below for it. Because once again, you'd be creating a separate variable with the same name. That would result in some errors. So C is true. Therefore, our answer is A. Question 19, we're looking for result 1 after calling new digits with a parameter 45. So jumping down to our function, x is equal to 45. A is equal to x mod 10 or 45 mod 10. That means A is equal to 5. Remember that when we mod a number by 10, we're isolating the ones digit. So we take the last digit of the number, assign it to A. Now we have B is equal to x divided by 10. That's going to be 4. We take the tens place digit, or any digit greater than the tens place. Now we have x equals A times 10, which is 50, plus B, which is 4. We return 54. So notice what we did. We started with 45. We ended with 54. We reversed the digits. Question 20. Now we're going to call the same function, but this time our parameters will be 213. So x is equal to 213. A is equal to x mod 10. Well, just like last time, we said this is going to be the ones place, so 3. And B equals to x divided by 10. So be careful here. This is not just going to be the tens place, but any place greater than or equal to the tens place. So this is going to be 21. So now when we say x is equal to a times 10 plus b, we have 30 plus 21. So our final answer will be 51, or B. Notice that this time we did not just switch the digits because it was the input number had more than 2 digits. So of course we want to find these shortcuts, but we can't make too strong of assumptions if we don't totally know what the code is doing. Question 21. Now we're doing the same thing, but our input is only 1 digit, the number 7. So once again, a is equal to the 1th digit. 7 divided by 10, integer division, we don't care about the decimal, so it's going to be 0. Now we have 7 times 10 is 70, plus b, 0. So we have 70 as our final answer. So in some sense, we did switch the digits, if you thought of the number as 0, 7, and not just 7. But we do need to be careful about this behavior. Moving on to question 22. Which of the following statements regarding user-defined functions is false? A. Not all functions that utilize pass by address are void functions. This one's going to be true. Right, a lot of times we do want to pass by address and also return normally, because it's the best practice that we want to be using their normal return statements when we can. So maybe we pass one by address and the other one return normally in a function like this. Right, so this function do this. We're going to return an int, but we're also going to pass by address because we need to have a second result or some sort of output from this function. So you can do both in one function. Therefore, not all pass by address is void. B. When working with a parameter that has been passed by address, it is unnecessary to use the address operator in the scanf because a pointer variable already represents a memory location. This one is also going to be true. So remember, if we call this function and do this, our call might look like this. Let's say value equals, do this. So let's pretend that other value is an integer. When we call the function, we're going to call it with the address of other value. So we put the ampersand in front of other value. So now, if we had a scanf and to do this function, we could just use the name result2. Because remember, result2 right here is the same as ampersand other value. So there already is essentially an ampersand there. Therefore, B is true. C. A function that passes at least one parameter by address must pass them all by address. This one's going to be false. So in our do this function, we could pass other value by address, but maybe we want to pass by value the radius and height of a shape. Those don't need to be by address because we don't want to make changes in the called function reflected back in the calling function. Right, those are just inputs to some calculation. Maybe the output of that then goes to other value. So we have a mix of pass by address and pass by value. Therefore, C is false. C is our answer. Question 23. Which of the following is the result of our first call to make changes? So for our first call to make changes, we're passing 5, 3. We're going to return 5 mod 3 times 3 mod 5. Well, as modulus and multiplication are at the same precedence level, we're going to read this from left to right. 5 mod 3 is going to be 2, right? Because we have one whole grouping of 3, 2 left over. 2 times 3 is going to be 6. 6 mod 5 is going to be 1, because you have one grouping of 5 and 1 left over. Therefore, our first answer is going to be D, none of the above, because it returns 1. Moving on to question 24. We're going to call it some new parameters. So we're going to call it with x++. Well, this is postfix, which means we're going to make the change later. So for now, we're going to use the current value of x, which is 5. Then plus plus y, because it's a prefix increment, we're going to make the change now and use the new value. So now we have x and y are 5 and 4 respectively. 5 mod 4 times 4 mod 5. 5 mod 4 is 1. 1 times 4 is 4. 4 mod 5 is 4, because any number mod a larger number is that first number. So therefore our answer is B, 4. As a side effect of this line of code, now we're going to make that change to x because we're done with all our calculating. Finally, for question 25, we have this nested call. So we're going to start with the inside call and then work our way outward. So make changes. 7 4. 7 mod 4 is 3 times 4 is 12. 12 mod 7 is going to be 5. So we have x is 6. This function result is 5. So now we're going to make changes one more time with our inputs as 6 and 5. 6 mod 5 is going to be 1. 1 times 5 is going to be 5. 5 mod 6 is going to be 5. Therefore, our answer is A, 5. Question 26. Which of the following statements regarding course standards and user-defined function design is true? A. With the use of pass-by-address, it is now permissible for a function to be written to complete several subtasks of the program. So this is false. Remember that functions will always need to solve only one task to have good function design and good program design. This is important because if you want to change the flow of your program later on, and you only want to do one part of what a function has, because you made it do multiple tasks, now you're going to have to rewrite your function in multiple parts. So just because we can use pass-by-address doesn't mean we will always do it, because we don't want to actually change the purpose of a function. So A is false. B, it is good design practice to create a user-defined function that is testable apart from the rest of the program. This one is true. So if your user-defined function, given some inputs, is going to calculate the area of some shape, right? You can choose some test inputs, call that function, and then print the return value and see if that matches with what your calculator says. Even if the rest of your program doesn't work or hasn't been written yet, you can at least check that that one calculate volume function works on its own. You can do the same thing with all your different types of functions. Meaning you can write one, test it, add another function to your program, test it, and keep building up until you're done. So B is true. C, a function that accomplishes multiple processes is functionally cohesive. This is false. Similar to A, we're saying that every function is doing its purpose properly when it completes one task fully, but only one task and no more. So one and only one task you have to remember with a function. So our answer is B. Moving on to question 27. Which of the following is the correct use for the srand function call? Well, let's remember what is the point of srand. The srand function is to establish what our seed that we're going to use for the program is. So, if you think about it logically, if we're just telling the program what to use, we don't expect anything to be returned. So therefore, there should be no seed equals. And we do expect to pass some value to it because we're telling it what to use. Therefore, B, even if you don't remember how to write srand, makes sense. We're given an instruction and we don't expect a return value. Question 28. Which of the following is the smallest possible value assigned to the length 2 variable? Well, for input is 210 and length equals rand mod A plus rand mod B. We know that it could be any number mod something. At minimum is going to be 0. If the if rand is equal to A or some multiple of A, and similarly with B, therefore they would both be 0, and our result would be A, 0. Note that these are two separate calls to rand. So you could have something for your first call that is a multiple of A, but not a and then your second call could be something that's a multiple of B, but not a multiple of A. And that's okay because they're two separate calls. Each time you call it, you'll get a different number. But regardless, our answer is A, 0. Question 29. Which of the following is the largest possible value assigned to the length 3 variable? So A is 150, B is 5. So here, remember that any number mod something at most can be 1 less than that number. So any number mod 150 at most could be 149. If it was any higher, then it would be another full grouping, and you could basically jump back to 0 for your remainder. Similarly, any number mod 5 at most can be 4. So the largest possible value would be 153. Therefore, answer is D, none of the above. Now we have some pass by address for questions 30 and 31. There's a lot of different ways to talk about this, so I'm going to switch up as I go, using different terms to describe pass by address. Hopefully at least one of them will be helpful. So we have this function that receives two addresses of ints. So we're going to pass ampersand A and ampersand B. So we see that the address, or the value stored at address AX is going to be equal to the value at address AX minus the value at address AY. Another way to say this is variable A in main is equal to the value A in main minus the value B in main. So simply, this is just A equals A minus B, or 11 minus 8. So now A is equal to 3. Now we have the value stored at address AY is equal to the value stored at address AX plus the value stored at address AY. Or, in other words, B is equal to A plus B. B is equal to 3 plus 8. So B is equal to 11. Now we have A is equal to B minus A. A is equal to 11 minus 3. A is equal to 8. Notice that all these changes I'm making to the variables in main because we use pass by address. Now we're going to call the same function. We're going to pass ampersand B and ampersand C. Once again, the value stored at address AX, which is a different address now, is equal to the value stored at address AX minus the value stored at address AY. Or B equals B minus C. Well, B minus C, 11 minus 12 is negative 1. So B is equal to negative 1. I'm going to quickly go through these last two lines. Hopefully you've gotten the hang of it by now. C is equal to b plus c, c is equal to 11, b is equal to c minus b, b is equal to 12. So now our answers are going to be A and C are 8 and 11 respectively, and B is 12. So 30 is A, 31 is C. Question 32. Which of the following statements regarding structure charts is false? A. Each rectangle on a structure chart represents user-defined functions used in a program. This is going to be true by definition. If you need a review of what the different symbols mean, I would review the textbook or notes packet. B. A structure chart demonstrates the order in which user-defined functions are called in a program. Right, we're going to represent that order by left and right, as well as up and down, based on if it's the main calling the function or we have a flow between multiple functions calling functions. C. The passing of data to user-defined functions in a program can be indicated on a structure chart. Right, for this we can do something like arrows with an annotation above the arrow saying what is our parameters we're sending to the function or what is the information we're receiving back. So based on the directions of the arrows, we can quickly identify if the function is void or if there are no parameters based on where the information is flowing, or if it's not flowing at all between functions. Therefore, all of these are true by definition, really. This is a good one. If you don't know, go back and review the textbook. Question 33. Which of the following is the first line of output generated by the program above? I think this is the easiest one to just go through and do the math. So we're going to start off with our parameters, x equals 5, y equals 4, and z equals 3. So f1 equals, and I'm just going to put the numbers straight in here, 5 divided by 4 plus 5 divided by 3. Remember, we have integer division, so the results are going to be in integers. And we're going to respect precedence and do division before addition. So 5 divided by 4 is 1, 5 divided by 3 is 1. 1 plus 1, or 2. Now, f1 is equal to 1 divided by f1 times 5. 1 divided by 2 is 0. 0 times 5 is 0. So f1 is equal to 0. How about f2? We have y divided by x plus y divided by z. 4 divided by 5 is 0. 4 divided by 3 is 1. So f2 is equal to 1. f2 equals f2, or 1, mod 2 times y is 4. 1 mod 2 is 1. Any smaller number mod a larger number will always be the first number. 1 times 4 is 4. So f2 is equal to 4. Now we have this long equation right here, but you may recognize what's going on. I'm going to use a different color for this. Notice what I put in the black box. Does this look familiar in the form x plus 2 mod x plus 1? Well, our x is equal to f2 plus f1. If we make an input-output table for the x plus 2 mod x plus 1, I'm going to give the inputs 0, 1, 2, and 3. The output, 2 mod 1 is 0. 3 mod 2 is 1. 4 mod 3 is 1. 5 mod 4 is 1, and so on. So any number for x greater than 0 is going to have an output of 1. If the input is 0, then your output is 0, obviously. So how do we rewrite this line? Well, I'm going to create a simpler, kind of more English input-output table. If our x, which is f1 plus f2, is 0, then f3 is equal to 1 minus 0, or 1. If f1 plus f2 is greater than 0, then f3 equals 1 minus 1, or 0. So this line is going to be represented by this input-output table. So in this case, f1 plus f2 is equal to 4. 4 is greater than 0, so f3 is equal to 0. Now f3 equals its current value times z. 0 times 3 is 0. Therefore, f3 is equal to 0. We return back the sum of our three f variables. 0 plus 4 plus 0 is equal to 4. Moving on to question 34, we have the same problem with some new inputs. I'm going to keep this table from the last question on the side so we can speed up our work. X is equal to 3, y is equal to 3, z equals to 4. f1 is equal to 3 divided by 3 plus 3 divided by 4. That's going to be 1 plus 0 equals 1. f1 is equal to 1 divided by 1 times x. That's going to be 3. So f1 is equal to 3. f2 is equal to 3 divided by 3 plus 3 divided by 4. 1 plus 0 is equal to 1. f2 equals 1 mod 2 plus y, times y. 1 mod 2 is 1, 1 times 3 is 3. f2 is equal to 3. Now for f3, we are using the same table we created in the last question. f1 plus f2 is greater than 6, which is greater than 0, so f3 is equal to 0. f3 equals the current value of f3, which is 0, times z, which is 4. 0 times 4 is 0. So now we return back the sum of our three f variables. 3 plus 0 is equal to 6, so our answer is A.